Alex, I spent 20 years thinking that if a tool didn't involve a rotating blade or a 5 pound hammer, it wasn't really making. I looked at laser cutters like they were just high tech printers that smelled like a campfire. But I tell you, once you see a beam of light vaporize a perfect joinery slot in about 4 seconds, you start looking at your hand saws with a bit of a wandering eye.
Oh, so you've officially crossed over to the dark side? Or the light side, I guess, since we're talking about lasers. I remember the first time I saw you around one. You were standing 3 feet back like it was going to explode.
Well, when you've spent half your life avoiding things that can take a finger off, a machine that uses an invisible heat ray deserves a healthy amount of suspicion. But that's the magic of these things. It's a CNC machine, computer numerical control, but instead of a spinning router bit, it's using concentrated light. It's the ultimate bridge between that messy sketch in your notebook and a physical object you can actually hold.
It's definitely less intimidating than a table saw, but I think people underestimate the learning curve. They think they can just hit print and a birdhouse pops out.
If only. My first real attempt at a complex box with a laser was, well, let's just say it looked more like a charcoal briquette than a container. I didn't account for the fact that wood is basically just fuel for the fire I was intentionally starting. I set the speed way too slow, and before I knew it, my precision cut was a 1/4 inch wide and glowing red. It's not just about the light, it's about managing the destruction.
That's a good way to put it. You're basically controlled burning your way to a design. But before we get into the Tiger's Shop Fires archive, let's break down the tech for everyone. Not all lasers are created equal. You've got diodes, CO2, and fiber. For someone just looking to get their feet wet, where do they even start?
Most folks starting out at home are going to be looking at diode lasers. They're the tabletop entry point, they're compact, relatively affordable, and great for engraving. Think of them like a very precise, very hot pen. They're brilliant for leather, wood, and some dark acrylics, but if you want to start slicing through 1/2 inch plywood like it's butter, you're moving into CO2 territory. Those are the big cabinets you see in maker spaces. They use a gas-filled tube and mirrors.
And fiber? That's the high-end stuff, right?
Total different animal. Fiber is for the metalheads. If you want to permanently mark stainless steel or cut through aluminum, you need a fiber laser. But for most of us in the Tiger Den world, makers, woodworkers, crafters, it's a choice between the accessibility of a diode or the raw power of a CO2.
So walk me through the workflow. If I want to make, say, a custom engraved coasters set for my brother's wedding, what's the actual A to Z of that?
It starts on the screen, not the shop floor. You need a design. You've got 3 main languages the laser speaks: cut, etch, and raster.
Is etch just a fancy word for engrave?
Pretty much. Think of it this way. Cut means the laser goes all the way through. It follows a line like a microscopic jigsaw. Etch or vector engrave follows that same line, but with just enough power to scar the surface. Then you have raster, which is the laser, acting like an old inkjet printer. It moves back and forth, left to right, firing tiny pulses to create a filled-in image or a photo.
Right, so if I'm using something like Lightburn, or even a design tool like Kittle, I'm basically telling the machine, follow this blue line for a light scratch, follow this red line to cut it out, and fill in this black area with dots.
Exactly, but here's the rub that most beginners miss: line weights and duplicate lines. I remember doing this intricate lattice design once. I had accidentally doubled up my lines in the software, 2 circles sitting right on top of each other. The laser did the first pass perfectly, then started the second pass immediately. Since the wood was already hot and the structural integrity was gone, the whole thing just vanished, just turned into a hole.
So the machine was just being too obedient. It did exactly what you told it to do, twice.
Exactly. You have to be a bit of a neat freak with your digital files. Join your lines, delete the duplicates, and for the love of all that's holy, make sure your text is converted to outlines. If the laser can't see a path to follow, it just gets confused and sits there staring at you.
Let's talk about the bed of the machine. I saw a tip about bridge pieces. What's the deal there?
Oh, that's a classic shop saver. Most lasers have a honeycomb or a grid bed. If you're cutting out a tiny piece, say the I in a name tag, the moment the laser finishes the circle, that little bit of wood drops through the grid into the abyss of the crumb tray.
And then you're fishing through a pile of charred offcuts like a raccoon in a dumpster.
I've been that raccoon. The trick is to leave a tiny bridge or a tab, a micro break in the cut line that keeps the piece attached to the main sheet. You just pop it out with a craft knife later. It saves you from losing your mind and your parts.
That looks incredible. But I've heard you can't just throw any material in there. I mean, I know you love to experiment, Tiger, but I'm guessing some things are off limits?
This is the one place where I don't joke around. Safety with lasers isn't just about goggles, it's about chemistry. You never, ever put PVC or vinyl in a laser.
Because of the fumes?
It's worse than just stinky. PVC releases chlorine gas when it's hit by a laser. Not only will that dissolve your lungs, but it'll actually corrode the internal workings of your machine. It turns your expensive laser into a rusty paperweight in a matter of hours. You always want to check the MSDS, the Material Safety Data Sheet. If you aren't 100% certain or 100% sure what's in that plastic, don't let the beam touch it.
So, wood, leather, paper, some acrylics, safe. Mystery plastics and vinyl, stay away. Got it. What about the fire aspect? You mentioned your charcoal box earlier.
Air Assist is your best friend. It's a little compressor that blows a constant stream of air right where the laser hits. It does two things. It blows the flames out before they start, and it keeps the smoke away from the lens. Without it, your cuts look like they were made with a blowtorch, all charred and messy. With it, they look like they were sliced by a scalpel.
It sounds like there's a lot of dialing in involved. I'm guessing you don't just guess the settings?
You can, but you'll go broke buying scrap wood. I keep a recipe book now. Every time I get a new batch of Baltic birch or a different hide of leather, I run a test grid, a little square pattern that tries different speeds and power levels. It's boring work for 10 minutes, but it saves you 10 hours of frustration later.
Okay, so let's say I'm sold. I want to add a laser to my shop. Besides the machine itself, what are the invisible costs people don't think about?
Ventilation is the big one. People see those tiny desktop units and think they can run them in a spare bedroom. Unless you want your house to smell like a burnt shoe for a month, you need a way to vent that smoke outside. Or a very high-quality charcoal filtration system. And then there's the software. Lightburn is the industry standard for a reason. It's worth every penny. But it's an extra cost to factor in.
And maintenance? I'm assuming you can't just let the sawdust pile up.
Definitely not. A dirty lens is the number one cause of my laser isn't cutting like it used to. Smoke residue builds up on the glass, the beam gets diffused, and suddenly your 20-watt laser is performing like a 5-watt flashlight. A bit of IPA, isopropyl alcohol, keep the beer for later, and a lens wipe once a week makes a world of difference.
So, what's the coolest thing you've made recently that you couldn't have done without the laser?
I actually did a topographical map of the lake where my grandpa used to take me fishing. I took the depth data, cut out about 12 different layers of thin wood and stacked them up. Doing that by hand with a scroll saw, I'd still be working on layer 3 and probably would have retired from the shop out of pure spite. On the laser, it was a weekend project.
That's the emotional beat perfectly. It's not about replacing the handmade feel. It's about expanding what's possible for one person to do in a shop.
Well said. It's just another chisel in the drawer, Alex. A really, really fast, light-powered chisel.
Any final tigerism for the folks at home thinking about pulling the trigger on a laser?
Just remember that the machine is only as smart as the file you give it. If your design is a mess, your project will be a mess, just a very precisely cut one. Take the time to learn the software, respect the fire, and for heaven's sake, keep your eyes on the machine while it's running. A laser is the only tool I know that can turn a masterpiece into a campfire in the blink of an eye.
Good advice. Don't be a raccoon and don't burn the shop down.
That's a pretty good rule for life in general, honestly.